Yeah, we've shown how to compute the spectral indices using the normalized difference approach in Earth Engine. We're going to consider the second approach, which is more of writing an expression. So this is also a method that is available in Earth Engine, but it is often used and is sort of more robust and in terms of understanding remote sensing, because spectral indices, they are just arithmetic where you are just dividing or multiplying or sometimes adding and subtracting bands. So you want to write that kind of formula so that you use it. So that is more intuitive and more robust in terms of computing spectral indices, and this is what we're going to use here. So I'm going to demonstrate that by exploring Savvy, and then if time is available, I'm going to do the EVI. So once I've done these two, I expect you to follow the same steps, to do the other vegetation indices. So the tool to use here, what I'm going to do is I'm going to choose everything. I'm going to choose all of these things. So what I'm going to do is just to highlight everything here for now, and then I'm going to click. I'm going to hold on shift and control at the same time, and then the single forward slash, and then just turn everything into gray. Sorry, turn everything into green, right? So once everything turns into green, that means that that line or those lines of code are not going to participate in the script anymore, and because they are all switched. So what I'm going to do now, I'm just give myself some space here, and then I'm going to go to um, image, and then there's a method called expression, right? So this is it. So expression. So this method requires two arguments. The first argument is the expression, and the second argument is map. All right. So what does this method mean? It means that you can evaluate an arithmetic expression on an image. Okay. So the argument expression, what does that mean? So it should be a string, and this is what the expression to evaluate. So the spectral indices have got formulas, so we're going to write the formulas by using this expression. I'm going to demonstrate this very soon. And then the other argument, the second argument, is what? A map. And what does that mean? It requires a dictionary, and that is actually optional, okay? But we're going to take this option, and what that means is that it is what a map of input images available by name. So based on this thing here, this description here, I'm going to construct or compute those vegetation indices. So what I'll do is that I'll just copy the method here, and I'm going to put two forward slash to make it appear as a comment, but I have to define this expression and that. So I have to define this argument and that argument. So the name of this argument is given to us as expression, and so I'm going to uh, create a variable. I'll just paste it here. And then what I'm going to do now is to um, assign it. And this is where I'm going to now look what is the formula. I'm going to write the formula for um, Savvy. Okay, so I'll look it up. So when I type in Savvy formula, so this is the formula. So in the near infrared minus red, all divided by near infrared plus red times the um, the L, which is actually count for the background, the soil background, how transparent the soil background is. So we use the survey to monitor the health of vegetation in uh, environment that vegetation is sparse and typically in arid environment. So you're going to use that. So we are going to use the brightness correction factor to be 0.5. So this factor we are going to take 0.5. So in the place of L, we are going to put what 0.5. So we are going to write this expression. This is the formula. We are going to write this formula in the expression here. So that is what we're going to do. And so it's going to be what is when you go back here, it says that that should be a string. So we're going to start with a string. So this is going to be me writing a string here. So this is double quote here, and that is a string. And so I'm going to compute my formula here. So I'm just going to look it up here, and the near infrared minus red. So okay, so I'm going to write that to be near infrared minus red, and then all divided by near infrared plus red, and then plus the correction factor, which is 0.5. So it is this thing that I'm trying to um, write here in the code editor. So once I have got that, and then I'm going to put all of this in a double round bracket, so it can compute it in the sense that um, you have the whole of this thing divided by the whole of that. Okay. So once I go back to the formula again, then there's a multiplication. So multiply by 1 plus the correction factor. So, and that is what I'm going to do here. So the multiplication is this asterisk here, and into bracket 1 plus 0.5, which is 1.5 if you like. And then this is, so I'm trying to replicate the formula as I see here. So that is what I've done here. So once you have done this, you have defined the expression. So I'm going to assign this to a variable. Okay, that is the conversion in Earth Engine. You have to assign it to a variable, and so I've assigned this to a variable. Okay. So we have created the object for expression. The next object is this one here, map. Okay, so we're just going to copy map here. So I'm going to paste it here, and then I'm going to create a variable map. And then what is map? I don't know what it is. I need to go back to the description here, and then okay, that is going to be a dictionary. So a dictionary is what? Curly brackets. Dictionary is represented using curly bracket. So I've got this curly bracket here, so it means that it's dictionary, but it's empty. So at the moment, I have to tell the computer what NIR, near infrared, means, what red is. So this is where I'm going to select the band. So if you go to console and you come here, you select the bands that you use. So, and the near infrared band, which is NIR, is band 8 here. So I'm going to tell the computer that okay, here the NIR is oh sorry, is the image. Then select this one here, right, 8, because that is the near infrared. The near infrared is band 8. So this selects this selects the near infrared band. Okay, that is what it does here. And so I'm going to put comma here. Then I go and also tell the computer what red is. So I've defined what the near infrared is. Now I need to go and tell the computer what red is. So the red is band 4, right? So the key is red, and then I'm going to same thing here. I'll just copy this here, and then I'm going to select the band 4, which is B4. So I'll just change this to B4, and this what this is this does what this also put comment around it just for yourself. So I'm going to stick it here, and then this select what the red band. So this is red band. Okay, that is selected. Okay, So now I have defined what NIR means and what RED means by this one here. So I've defined it. So what I have done essentially is the two arguments the method requires. I have just defined them as objects. So what is the expression? Expression has been defined here, and what is map? Map has also been defined here. So now I am at the point that I can apply the method. So what I'm going to do is that I'm going to apply this method to the image. So this is the image here. This is the image here. So I'm going to take the image, and then I'm going to apply the method to that. So well, this is the image, same thing as the one here. So I'm going to now apply the method. Apply the method. So to apply the method, I need the image, then apply. This is the interpretation of apply, and then this is the method. This is the method. I'm going to copy this method here, and then I'll stick it here, right? But remember that we've defined expression. Expression is this one here, so it's defined. So you can see it's defined. And map, which is this one, is also defined, so we can keep it this way. You need to define it before you can use it, otherwise you can't use it. So once this is done, I'm going to assign this to what a variable called savvy, okay, as savvy. And then what I'm going to do here is that I'm going to rename the band because I want it to be called savvy. So um, soil soil adjusted vegetation index. So now I've done this. The next thing is to print the results. So I'm going to print the result to the console. So I'm going to now print this and now call it savvy, and then I'm going to run this. Okay, just when it's finished running, go to the console and then see. You see it has created a band called savvy. So this is created here, but this is sometimes not helping us because we don't see anything. The best thing to do is to visualize it. So the next thing is that we are going to visualize. We are going to visualize the survey layer. Okay, we're just going to visualize it, and we've covered that already. So be sure you watch how to visualize a single band image as a grayscale and also as a shadow color image. Okay, so I'm going to paste my script here. So this is the object called survey, and the minimum value is -1, the maximum is 1. So approaching +1 means that the pixel is healthy, like a healthy vegetation. Anything away from 1 is low green cover. And normally you will use the survey in a arid environment or sparsely vegetation areas. And so I'm going to run this. Okay, once I run this, you see that you're going to have. I'm going to pull this one up a little bit, and then you can see this is the grayscale. So you can see healthy vegetation are the white pixels or the brighter pixels. But once you change it into the shadow color, then you can see that these are healthy vegetation. So you can see the green pixels are healthy, vegetation. And so again, you can always use the inspector to click around things and to see what is not vegetation or what is just a bare soil. And then you can see, this is about 0.69 healthy vegetation. So that is also a healthy vegetation. So there is actually not big difference between NDVI and Savvy. The only thing is that you have to think of your study area to say whether you are using Savvy or NV or the question you are investigating. So, like I said, in a low vegetation cover areas, you have to use Savvy instead of NDVI. Okay, so this is how you use the expression in Earth Engine to run through spectral indices. Okay. Okay, so yeah, that is it. So alternatively, sometimes you may lump everything into the script. So here what we have done is that we define expression, we define map, and then we used the method. All right. You could as well copy the whole of this, and then you stick it here, right? And then copy the whole of that this one here. You can copy the whole of this, and then you replace the map with it, right? And then what you could do is that once you have done that, you obviously it means that you don't want duplicate, so you're going to shush this one here, and then you'll be able to run, and then hopefully you're going to get the same results. That because you haven't really done anything, just that you replace those arguments with the expressions there. Okay, so this is how you can use the expression to compute savvy. We are also going to look at it in terms of um, enhanced vegetation index. Okay, so continuing from survey, we want to look at the enhanced vegetation index, which just function like survey or NDVI, and we're going to use the expression to do that. So um, we got it as one of the tags. So the best thing to do is that what is the formula for EVI? So just look it up, and this is the formula for UVI. Sorry, the enhanced vegetation index, which is EVI. So the formula for enhanced vegetation index is 2.5 times, and the bands that we require here: near infrared, red, and then blue. So we're going to require um, blue band in addition to red and the near infrared. So we're going to sort of write this formula in the expression. Okay, so let's head over to Earth Engine. So this is the survey we did. Okay, so now with the so in applying the expression, we know that we require to argument expression and map, and so we have defined the expression, which is actually the formula you see here. So that is what we have included here, right? And so we need near infrared, red, and a blue. So when it comes to the other argument, which is map, and where we are trying to define the bands we require, it is a dictionary, and then we select band 8, which is near infrared, band 4 is red, and then here blue is what band 2 that we have defined. So now we've defined the expression, we have defined the map, so we can now apply the method, right? So we're going to apply the method. So we call the image, and the function is expression, and the first argument is also expression, and that we have already defined upstairs in line 75, and then map defined in line 76. We just use it, and then we rename the whole thing. This whole thing here, we'll rename it as what EVI, so that the layer will be called EVI, which is enhanced vegetation index. And this is where we are doing the visualization. So we are visualizing the enhanced vegetation as a grayscale and also as a pseudo color. So I'm going to run this. Then once you run this, you will see in the layer manager the two layers. So the first one is a gray scale, which is healthy vegetation. So the green you see here, they are dense and healthy vegetation. And so that is how you use the expression to display spectral indices. And so I expect you to use this knowledge, to be able to you create NDVI and the other vegetation indices or spectral indices using the expression method. Okay, so once you have finished with your code, always you need to save this code. Okay, so you have to click save, and then here I'm going to call it what spectral indices. So spectral this is in this case, so it's not. I'm going to make this one up I, then just click OK, and then wait for it to gray out. Once it grays out, see now it's grayed out, so that means that that is saved, and then you should see it here in your script. So if I go to my script now, I should see a script called what's spectral index. This one here, spectral indices. Okay, so this is how you compute and visualize spectral indices using Google Earth Engine. Thank you for watching, and please subscribe to the channel for more videos.